Okay, so talking about tangents today. Tangents, this is a different kind of tangent than like a trigonometry tangent, okay? A tangent is a line. And there's your definition, so you'll want to get that down. A tangent to a circle is a line in the plane of the circle. That just means that, like, the circle's not this way and the line is this way. It means it's all in the same plane, okay? That intersects the circle in exactly one point. So a tangent line kind of brushes along the top, or doesn't have to be the top, brushes along the side of the circle, okay? So anywhere else I were to draw a line, it would intersect like two places. A tangent line hits it in exactly one spot. Okay, so it just kind of like skims the edge. I'm going to erase some of my drawings here. So you can see in this diagram that the line up on top, that would be called a tangent line. So this line is a tangent line. The point of tangency is X because that's the point where it hits the circle. Okay? I want to draw in a radius of this circle up to that point of tangency. So there's the center of my circle. Here's my radius that's connecting to that point of tangency. And I just want you to look at that for a minute. What do you think might be true there? Bisect. It doesn't necessarily bisect because it's a line that goes on forever.
They're perpendicular.
There you go. It's perpendicular. Yep, and that's what your next slide talks about. Okay? A line is tangent to a circle if and only if it is perpendicular to the radius at the radius's endpoint. Okay? And we'll talk about that related theorem in just a minute. But the big thing I want you to get right now is that anytime you have a tangent line, you have a right angle right there. This is the radius tangent theorem. And I know that's written in nice math talk there. The big thing I want you to take away from that is the perpendicular. Okay? That the radius is going to be perpendicular. Okay? There's a theorem that's related to that. And it's related to that because using that theorem I could prove this other theorem. If two tangents come from the same endpoint, so you can see like this line is tangent to the circle here. This line, whoops, let me side this up. This line is tangent to the circle down here. So these are both tangent lines. If they intersect here, if they share a point, then the distance from that point to the point of tangency is congruent. So those two pieces that I outlined in purple would have to be congruent. So when we're talking about tangents, usually we're talking about lines that go on and on forever. But notice that when you have this common endpoint, it kind of cuts that line off, and that's why you can say that those pieces are congruent. Okay? Questions on that at all? Okay. Okay, so here's an example for you. Segment YZ is tangent to circle X at Z. So it's telling you that this is a tangent line. I want to know what kind of triangle is this? What's the one thing that you just learned? I don't know for sure that it's isosceles, but it would be a right triangle, right? I have a right angle here. That's what I really know. And what do right triangles let you do? Pythag, what else? We just finished like 4 weeks on it. Trig, right? Trigonometry is all based on right triangles. So knowing this is a very like powerful thing. Okay, knowing that you've got that right angle there, because when you have right angles, you get right triangles, and then there's all kinds of stuff you can do with right triangles. All right, if the radius is 5, which segment in this picture is it talking about for the radius? XZ is my radius, yep. And ZY is 10, find XY. What could we do? Pythag, yeah. It's a right triangle now. 5 squared plus 10 squared equals C squared. Okay. That's going to be 125 equals C squared. What is it? 11.2 would be your final answer there. Good. All right. Find the area of that triangle. How do I find area of a triangle? That's it. Yep. Base times height divided by 2. Which two are my base and height? Caitlin, you know that one? Which two are my base and height?
Isn't 10 your base? No. Yeah, and 5's your height.
Yeah. 5 and 10 are your base and height. Doesn't matter which is which. Okay? But how do I know that those are the two I want to be using? Oh, because they make the right angle. How convenient, right? So for my area, I would do 1/2, yep, times 5 times 10, doesn't matter what order I go in there, and that would be 25 square units. Okay? So really, the big new part of the lesson today is that we have a right angle there, right? And then everything else is just stuff we already know. Okay, example 2. Oh, give me a minute to flip, sorry, I had to do that. Draw the line T tangent to circle Z and label all information appropriately. So if I'm drawing a tangent line, what do I want that line to do? Touch the circle at one point. And I don't care where you do that, and I might have a hard time doing it with this stylus, but oh, not too bad. We'll just make that my point of contact. So that's going to be my line T. What do I know about tangent lines that I could add to this circle? Like what else could I draw in? Yeah, so I could go from the center of the circle and draw a radius up to that point of tangency, pretending that I actually hit that point. And then label that with what? Oh, yep, the center should be Z, you're right. And then the angle, what can I say about the angle? It's a right angle, good. That's what I want to see there. Okay, I just want you to draw a tangent and a radius. Okay, a little more complicated picture here. If ZY and YW, so we're talking about this and this, are tangents, what is true about triangles ZXY and WXY? So I want to know what is true of these two triangles. Well, they would both be right triangles, okay? But there's something more specific we can say, and I don't remember. Look at your notes. I might have added it to yours. Oh, no, I guess not. Okay. We're going to be a little more specific. Let's talk about some of the stuff we know. Tell me something I know in this picture. Jackson.
That triangles ZXY and XYW are congruent.
Okay, that's what I want to know, but I want to know why. So let's
Because,
go ahead.
If two tangent lines meet at a point, then, if two tangent lines meet at a point, then the distance from the line of the point of tangency and the point where they meet is those lines are congruent.
Yep, you got it. Yeah. So from that theorem, that's that theorem that we just talked about, point Y, do you see that that's where my two tangent lines meet? This distance and this distance must be congruent to each other, right? So I know that those two things are congruent because it's the same distance away. What else do I know is congruent in this picture? Noah? Oh, this is congruent to itself, right? Reflexive property. That would be congruent to itself. What else is congruent? Rachel?
XC and XW,
How do you know that?
because it's the radius.
Yep, these are both the radii of the circle. So these are congruent. And this one is congruent to itself. Okay? So I can say, this is going back to what Jackson was talking about, that triangle ZXY is congruent to triangle WXY. What theorem did I just use? Like, why do all those markings tell me I have congruent triangles?
Radius tangent theorem.
Okay, that's how I know the purple lines are congruent. This is throwback. This is throwback to like first semester. Brooklyn?
I forgot what it's called, this one, all like angles and side lengths are all congruent.
Okay, so 3 side lengths congruent. What might I call that? Side, side, side. Yeah, this is side, side, side. Okay. By the way, what do I know about angles Z and W? They're 90 degrees. So I could have also said I know these are 90, and that would allow me to do SAS instead. That just wouldn't use the orange line. SAS. Or what else is there that's specific to right triangles? HL. There you go. So I could have used hypotenuse and then even just the radii of the circle without even using those purple lines. Or I could have used the purple lines and not the blue ones. So you could justify that those triangles were congruent using HL, SSS, or SAS. Okay? Kind of a throwback for you. All right, let me, well, I guess I'm going to have to do that. Let me rewrite what I had up here. ZXY. I just wanted my picture clear for that next example. And we used SSS, but you could have also used SAS or HL. That question's going to come back. You're going to see it again, by the way. Okay, if measure of angle ZYW is 88 degrees, what is the measure of arc ZV? All right, let's see what we can do with this. Tell me something I could do with that 88. Jake?
Could you cut it in half?
I sure could. So, because we know that those triangles are congruent, we just talked about that, right? We know these angles would have to be congruent. So this would be 44, this would be 44. Okay, what else do we know that might help us? Marty, do you know something? Like down here? These two are going to be the same as each other, but they're not going to be 44. But you're right. Let's target these angles. How could I get those angles down there? Okay, so I know that I have a 90 here and a 90 here. And so now if I look at just this triangle, I have a 90 and a 44. So what would this angle have to be? 46 if you subtract from 180. Whoops, I just wrote 48 again. I meant 46. So these would each be 46. How does that help me with arc, whatever the letter that is, ZV? Matt?
They're equal to each other.
Yeah, that's a central angle, isn't it? This 46, isn't that the central angle? Gosh, I need an all-new color. This angle matches this arc. That's a central angle. So arc ZY, or ZV, would be 46 degrees. Okay? So see how many things you can like connect and move around, and I'm telling you, I love circle problems. You might not share my love, but. So measure of arc ZV is 46 degrees. And then it says, what is the measure of angle ZUW? Ooh, look at that. What kind of angle is that? That's an inscribed angle. That's what we were doing yesterday. And that goes with this arc. Well, just a minute ago, we said this little part that we highlighted in green was 46. So what is that whole thing? 92. So this right here is 92 degrees. But then what do I have to do to that 92 to get this angle? Cut it in half. So we're back down to 46, right? Measure of angle ZUW would be 46 degrees. Okay? Lots of different questions I can ask you from one picture. I love these problems. Love them. You're going to see them lots. Okay. This is an interesting problem. This is a problem that I don't know if I just gave it to you, if you could see how to set it up. All right? Assuming there are no other obstructions, how far can you see to the horizon from the top of a 200-foot tower? And then I tell you that the radius of the Earth is 3,960 miles. Why on earth would you need the radius of the Earth?
Draw it out.
Okay, let's draw it out. So I'm going to draw the Earth. I'm going to do an excellent job of it, I'm sure. There's the Earth. Okay? Here is my tower that's sticking up on top of the Earth. Okay? So there's my tower that is 200 feet. And when I say that I want to look at the horizon, if I'm standing on the top of that and looking out, what is the horizon? Say it again, Franklin.
Across from it.
Not quite. Like if I was at the beach and I was looking at the horizon.
It's like if you're looking forward on something that's curved,
Mhm.
like the very base of what you can see.
Yeah, Earth-wise, it's when you're looking out, it's where you see the sky meet the ground. Okay, if there's nothing else in your way, if there's no trees or buildings or whatever. That's why usually you can see the horizon at the beach because it's just open water. It's where you see the sky actually meet the ground. And so what that really is that's you looking out from here and making a tangent line with the Earth. This point right here would be like where you can see the horizon. Okay, so if you were standing on top of that tower and looking out, this tangent point is where you'd be seeing the horizon. Okay? Well, if this involves a tangent line, we know we're probably going to need a radius in here, right? So let's go ahead and draw in our radius of the Earth. There's the center of my Earth. Where should I draw a radius to?
The point of tangent.
Point of tangency, okay, and I know that that's going to make a right angle. Where else do you think I could draw a radius? To the tower, yeah. So this is 3,960 miles. If I draw this in, I know up to this point is also 3,960 miles. What do I have here now? A right triangle, that's right. You see that? And what I want to know is the distance that I can see. So that would be this over here. I want to know how far is it from the top of the tower. Maybe I should do this on here because I'm recording. I want to know what's the distance from the top of the tower to that horizon point. This is what I'm looking for. Does that setup make sense now? Would you have never thought to set it up that way? Maybe eventually if I'd let you stew on it long enough. Okay. Anyone see a problem before we start doing anything? Hunter? No? Rachel?
200 feet with 309.
Yeah, I can't really add these two together because this is in feet. Here's what I would do to avoid making your numbers gigantic. I'm going to convert the feet into miles. So over here off to the side, I'm going to do 200. It's going to be weird, but divided by how many feet in a mile?
5,200.
Yep. 5,280. I'm going to get a decimal. That's okay. I'm going to need this over here by me anyway. 200 divided by 5,280 is 0.038. So I'm going to take out that 200 feet and make that 0.038 miles. So then my total distance here is really 3,960.038. Does that make sense? That I'm just adding that little bit onto that 3,960 miles. And I heard somebody say earlier, but what are we going to do? Pythag. Yeah, we're going to do Pythag here. Okay? So my setup is going to look like, and I'm going to set it up and then make it bigger so I can write. Here's my A squared, here's my B, here's my C. So I'm going to go 3,960 squared plus B squared equals 3,960.038 squared. Because that's my hypotenuse. I know that's going to seem like that doesn't make much of a difference, but and here's what I'm going to do with this one, just because the numbers are so huge. Instead of actually working out what this is and this is, I'm going to type it into my calculator all in one shot. So really what I'm going to do is just subtract right now 3,960 squared. Subtract 3,960 squared. That's not usually how I would go about writing this out, but just to avoid having to write all those big numbers. And so in my calculator, I'm going to type in 3,960.038 squared minus 3,960 squared. Just don't forget your squares.
Get like 39.9.
Okay. Yep. So B squared is 300.96. And then what do I still have to do to it? Square root it, yep. So B equals 17.3, but is that in miles or feet? That's miles. So that seems reasonable. I mean, you'd have to have really good eyes to actually see something 17 miles away, but what that means is technically you would have 17 miles of unobstructed view before you get that curvature of the earth in there. So looking back at my original picture, this distance here would be 17.3 miles, okay, from where you're standing on top of that tower to where you can see the earth curve, okay, 17.3 miles. Does that make sense? I know that one seems confusing, but the setup is going to be the same every time. The only thing that's going to change is what decimal goes here, okay? Okay, time for homework.